Welcome, everybody. Today we will talk about enterprise semantics. I think that's a pretty interesting topic we are facing right now in the semantic technology community. More and more enterprises are looking for a more strategic way to integrate semantic technologies into their enterprise technology stack. And I'm very happy to have Juan with me, Juan Sequeda from Capcenter, and together we will give this webinar.
Good morning, good afternoon. Thank you, Andres. So yes, my name is Juan Sequeda. I'm from Capcenter, and let me tell you a little bit about Capcenter. Capcenter enriches companies' relational databases by linking those databases with semantic web technologies, so we can improve search, analysis, and data interpretation. Capcenter has been founded by Dr. Dan Maranker and myself, and our key product that we have to offer is UltraWrap, which is a complete solution that bridges relational databases with the semantic web. UltraWrap allows you to run Sparkle queries directly on relational databases, and the key feature of UltraWrap is that it can run Sparkle as fast as SQL queries, and this is something that has not been achieved by any other tool. And we're able to do this because we make maximal use of the SQL optimizer. So in this presentation later on, we will have a little demonstration of what we have been doing to integrate Capcenter's UltraWrap with PoolParty. So back to you, Andreas.
Okay, thank you very much, Juan. Yeah, and so a few words about myself. I'm from Semantic Web Company based in Vienna. And yeah, we are doing semantic web projects since nearly 10 years now. And it's exciting to see linked data now becoming more and more important in that area. And yeah, we are on the market since about 4 years now with our PoolParty platform. Okay, today we will see a couple of use cases. We will talk a little bit about technologies behind enterprise semantics. You will see things about linked enterprise vocabularies, also a short introduction to the latest developments of PoolParty platform, and also I would say the low-hanging fruit, the concept-based semantic enterprise search, and last but not least we will give live demo of what Juan just mentioned. So we will show you how we integrated unstructured information, a large text corpus, together with information from an Oracle database, and we will give the demo live. Okay, so first step is what's the basic idea behind enterprise semantics actually. So just imagine, what if we could make queries by using our own words? That's the first part of enterprise semantics, our own words, not the words of other departments, other people, probably the words or the semantics of database engineers. No, our own words over a large variety of data sources in our enterprises as they were in one large knowledge base. So it's all about distributed systems, it's about networked systems. And what are the use cases here? It's actually three things, I would say. The first thing is concept-based enterprise search. So that's the next step towards a more semantic way to search. The second one is topic pages, 300 degrees views. So the symbol on the left side should already show a little bit the idea behind. It's not about looking at one thing from only one perspective now. It's about looking from different perspectives on a three-dimensional thing. This thing could be your product, your competitor, a place, whatever. But you would like to see more than just one perspective or only one perspective on that thing. You would like to have a multidimensional perspective. And the third use case for enterprise semantics are complex queries. So complex queries, as the little icon shows, is not like, where is my pizza? No, it's something which really is more complex to answer queries over usually more than just one database. So information to solve or to get information for complex decision making is usually distributed across your data sources. So the question is, how can we put those pieces of your puzzle together? Okay, so that's the three use cases, and I try to approach now step by step what's already on the market, how that works also, what are the more detailed use cases around those more or less generic 3 use cases we already mentioned here. Okay, the challenge is to link information from unstructured text like reports or news articles or things from your content management system in general with data from your databases. We know a lot about enterprise search. We know that there's a broad range of vendors and possibilities to build large indices over large document collections. That's all in place, and it works more or less pretty well. But the question really is, how can we integrate all the data from our databases together with this unstructured text collections? So that's one of the main challenges we are facing, because information overload, if you look closer to this buzzword, what is it really? Actually, it's a strange feeling of having a lot of data in many silos. Actually, we know we have enough data to make or to give answers to important questions, but somehow they are not really linked and accessible. And that's exactly the problem we would like to overcome in our enterprise information management. So first use case I mentioned before is the concept-based semantic search. So you probably know this picture or this image. This is not a pipe. So that should represent or illustrate the actual problem. Language is very fuzzy. We all know that. And the problem really is how can we establish a layer between our search interface and the actual information behind it. That this translation of our information needs we have is really guaranteed that you will find the right spot in your large document collections. So this is a little example of a little semantic network here. We see one is probably typing in pipe, for instance, and in a traditional in a traditional search engine, the person would not find the document which talks about ERW, which is a certain type of tube. And a tube is a pipe, and that's again something we would not find that easily if we were not in the position to have a semantic knowledge model in the background to build up a concept-based semantic search. So that's the difference between the traditional and the semantic search in general. And the second use case I was talking about, the topic pages, could look like that. So you collect data or information from different sources in your enterprise stack, like also from the web, from your content management systems, from different APIs, and you pull together information from different perspectives to build a big picture around a certain business object. In that case, a large company building cars. So you could probably provide people with not only these content mashups, but also with search assistants like displaying related concepts. If you had a knowledge model in the background, you could provide geographical search and things like that. So that's the basic idea about topic pages. Real life example is the energy country profiles. You can find on readly.info. The link is on the left side corner. And here exactly this happens on top of linked data technologies. There are 6 different databases in total, where data is around virtually any country in the world about energy consumption and projects in that area and stakeholders, events and things like that. And they're all pulled together automatically to build a 360 degrees view over a certain energy profile. And the complex queries we will show at the end of this webinar in a live version as well is, I would say, the most advanced use case we can build on top of enterprise semantics. As an example, for instance, you would like to have all reports in which at least one of your competitor and trends on markets are mentioned, in which your profit increased the last year by at least 2%. So just to make sure, it's very good to have more options to filter out the most important reports. You would like to make a combination with some sales statistics you have in your database. So what you usually do, probably as an analyst or as a sales manager, is you would do queries over different databases on your own. And you would put together the information probably in an Excel sheet and try to filter it out manually. So all those kind of questions are actually very relevant, but it's very hard to make it automatically done by a tool, except partly with enterprise search and except partly with typical business intelligence solutions or data warehouse solutions. But we are not trying to reinvent the wheel here. I'm not talking about typical data warehouse solutions here. It's more about how can we link data from different databases, unstructured and structured, without building a new data silo in the middle. We don't want to show here or showcase here a way how to build a data warehouse. It's really more about an agile way to integrate data all over the places. Okay, so that's more or less the roadmap towards the linked database search, the complex queries I've mentioned. So in recent years we had some semantic search around. It was still based on terms more or less, so the semantics was calculated by text mining and text analysis. But it's a big difference between this kind of semantic term-based search and the concept-based semantic search, as you can see, because as I tried to explain just before, you can do much more precise, in a more precise way, your queries if you have in the background a concept-based knowledge model. And you can also see that this second approach, the concept-based search, already is underpinned with some W3C standards. So it's a standardized way actually to search or to build semantics on top of your content. I will talk a little bit more about SKOS and RDF in a few minutes. And the third step, as I mentioned before, here you have already also all the necessary standards in place, like Sparkle or RDP to RDF and things like that. So it's all there now, not for a long time, I have to admit, but at least in 2012, finally W3C brought out all the standards we need for enterprise linked data technology stack. So it's all in place now, and I would say in about 2 years' time, linked database search will be rolled out on a broader scale on the market. Okay, so technologies behind enterprise semantics, before we come into the concrete demos and use cases. Just a few words on the linked data solution approach. So that's all what we are talking here about, how enterprise semantics should look like from our point of view. We should make use of all the standards W3C has released in recent years. For many reasons. One of the most important one is that you don't produce lock-in effects, the typical lock-in effects when you rely on a certain proprietary platform. You probably will never be able to get out of that. And if you talk about, for instance, Sparkle, you will see it's not that complex to link data from different data sources anymore. And there's more or less only one API, there's only one semantics, there's only one data model anymore. And the good news is you don't have to remove your databases. Just leave your Oracle database or your Postgres, SQL, wherever it is. You don't have to remove it. So it's more a virtual layer on top of the existing databases what you will produce, and on top of that layer, of the semantic layer, you will do the data integration. But you will see the difference in a minute on a picture. The semantics will be outside of the actual data silos. It won't remain inside. That's the point. So another lock-in effect actually will be removed then. So that's more or less how it could look like from a pretty traditional, so it's a transition here what you can see. The first step is, okay, you could of course set up another database, probably a large triple store, a large RDF database, where you could store unstructured text by doing entity extraction on top of your terminology. The terminology probably is already in a SKOS format, so you have that in place. Then you could also interlink it with stuff from the web. There's a lot of RDFA already in place. Of course, you can wrap or transform XML documents. And as Juan was pointing out, of course, also your relational database at that point. And all together, that's one point, very important. All data will be in one data model on top of RDF, and only one semantics will describe all your data. And here you are going to use SKOS, the Simple Knowledge Organization system of W3C. And as you can see, all those things are already standard of W3C. Juan, maybe you want to drop a few words already here about the standard to describe the data in a relational database?
Yes, as it's stated there in the presentation, R2RML and its sister standard, which is a direct mapping, have been recently standardized, forgive the redundancy, by the W3C in last month. And it's finally, it's been several years of work that we have been able to now finally roll out these standards. Direct mapping is an automatic way of exposing the relational databases to semantic web standards, and R2RML will let you manually customize the types of mappings that you want to do. And so these are now part of all the stack of standards that Andreas is talking about. And UltraWrap obviously will supports both of these standards and much more.
Okay, thank you, Juan. So yeah, that's the good news. It's all in place now, and actually there will be only one way to retrieve data from all the different data sources, and that's SparkQL. So with SparkQL or Sparkle, you're able to, if you learn just this one language more or less, and you know more or less the semantic model behind it. You don't know anymore how the databases look like or the XML structure or whatever. That's not the point. The point really is that those people doing the application development on top of SparkQL, they just learn the semantics behind the whole data, and they are able to build applications on top of it. So you see there's a very strict a strict line between the data layer and the semantic layer, and so you can really talk about probably even new job descriptions which will be built on top of that in the near future. Okay, now the question of course could be, okay, is this yet another data silo? Well, we as you will see, have been working on top of the federated query proposed W3C standard. It's not a full standard yet, but it's on its way. And what you can see here is more or less you're exposing for each of your data source a Spark endpoint into the cloud, into your enterprise cloud, for instance. And on top of that, you can do queries across the different data sources. Once again, there's just one data model and one semantics, more or less, which you are going to use. It's all integrated in this explicit semantic layer I'm talking here about. The data itself will remain where it is. So you really put a new layer, more or less, on top of the data, you need to give answers to these complex, more or less complex queries you would like to give answers to. So that's the whole idea now. Okay, so what else is missing if we talk about enterprise semantics? Of course, we need vocabularies. We need to clarify what is meant if someone says pipe. What is meant by saying that? What is meant by pipe if someone is searching for such a thing? Is it a product? Is it a company? Is it a person? And so on and so forth. And the problem here really is if we talk about enterprises. Enterprises usually are meant to be a very large system, a large distributed, decentralized networked system, more or less. And of course, in each department we are talking differently. We have using different vocabularies. The question really is how can we link our enterprise or our department vocabularies? And that's exactly the point I would like to talk about in the next 3 minutes. So, business groups share common processes and topics, but how do they communicate? That's the actual question. So if marketing talks, for instance, about innovation management, do they talk about the same thing when HR is talking about innovation management? Do they have the same things in mind? Do they use the same word only for different things? Or is it really the same concept behind? So how does common understanding actually work like? And that's the question we are facing in these days more and more because on the one hand we have globalization, on the other side we have localization. So for instance, if a marketing department in the US talks about luxury car, you can assume that they mean something else as when a luxury car is mentioned in Europe. It's a different concept. It's just the same name, but there's no standard in place at all. So what's the solution for that? Should we standardize luxury car on a global scale? I don't think so. I really think that it's much better to leave knowledge where it is, or also language where it is. It should remain or stay local. But on the other hand, we need means to link those two things if we are talking about large, globally acting enterprises. So actually the point is if research in that case, another department, looks for instance for lean manufacturing, they should also find things from production or fall that talk in a different way. Probably they mean the same thing by saying different words, and those things should be well connected to each other. And that's exactly the idea about linked enterprise vocabularies. So let's take a look at that. How could it look like if you had a tool in place which helps you to link your enterprise vocabularies? So for instance, on the right side you see the standard thesaurus for economics, and there is a concept called lean production. So this STW thesaurus is pretty well known, widespread, used by many document collections already to annotate and categorize. And probably in your company, nobody talks about lean production. They all talk about lean manufacturing maybe. Or let's assume production, your production department is using the standard thesaurus for economics to categorize information. And lean manufacturing is not in this thesaurus yet. So should we enforce that they should use my language if I'm a researcher? No, I don't think so. It should be two vocabularies in place, well connected to each other. And that's exactly what SKOS can provide as well. SKOS provides matching properties to make mappings between concepts from two or many thesauri. So how could it look like? For instance, you have one vocabulary in your research department, and here the preferred label is lean manufacturing. And there are other things around it. There's probably also different concepts around this lean manufacturing concept here. There's probably scientific management, there is Kaizen as a related concept. So research always has something else in mind as production would have in mind when they talk about lean manufacturing. They call it lean production anyway, and they have, for instance, just in time in mind when they talk about lean production. But still, those things are related to each other, and so here SKOS close match will help us to make this relation. And on top you see the core vocabulary. That's probably a proper architecture for building up enterprise vocabularies in general. You have a core vocabulary and all the different department vocabularies, and they're somehow linked to each other either with exact match or with close match, and there are a couple of other SKOS properties. And the nice thing is, if you have a core vocabulary, you can also do a mapping to things which are out on the linked open data cloud, like DBpedia. You could do a mapping to all the data which is on the worldwide semantic web. And then you can do queries across different databases in your own words. That's the point. So obviously linked data alignment is key. That's one of the really main features your enterprise semantics architecture should provide. There should be a tool which helps you to annotate, to align enterprise vocabularies more or less automatically. That's obviously one of the big points here. So I proposed here 3 different tools which are good enough to do this task. So just feel free to try them out and see how they can help you to align your enterprise thesauri. So since I'm now at the point of describing the importance of enterprise vocabularies, I would like to give you some information about the latest developments of PoolParty platform. I assume some of you listening to this webinar probably don't know PoolParty at all. Some of you probably know it already a bit better, and so it might not necessarily be interesting for all of you, but it will refer very much to what I've said just before. So the Advanced Thesaurus Alignment facility, which will be part of the next release of PoolParty Thesaurus Server, is one of those latest developments I would like to point out. So you can see here, for instance, you probably have a vocabulary about green energy on the very left side. And now you would like to make an alignment to an already existing one, which is probably the REAP thesaurus or the RIGI thesaurus on renewable energy, which is already well established and used by many organizations to annotate and classify content. And now you would like to link to this to get more or less means to interpret their data. So now you can link your project or your thesaurus to the renewable energy thesaurus, and the alignment will be done more or less automatically. So you can drag and drop parts of your thesaurus on the other one, on the target thesaurus, and then the alignment will be calculated more or less automatically, and you can curate the results and say, yes, that's correct, that's the correct alignment, or no, that's not correct, or it's not an exact match, it's rather a close match, things like that. So that's how PoolParty can help you to align your enterprise vocabularies. Then another latest development of PoolParty I would like to point out is the PoolParty power tagging feature we've integrated with SharePoint and Confluence now already. And what's the idea behind it? Actually, tagging can come in 2 flavors. There's this concept tagging, which is based on enterprise vocabularies, and there's this term tagging we know from Web 2.0. But there, of course, is a big difference between those 2 things, because I will point it out once again. Concept tagging really is the precondition for a semantic search in a second generation meaning. So I just pointed out before. So concept tagging and term tagging can both be done by power tagging, and the whole idea behind it is that these new terms, which are not a concept yet, should be somehow be pushed into the enterprise vocabulary later on. And that can be done with the new PoolParty API. So that's one of the methods we provide here. So if you have a CMS and you detect new terms which are not in your vocabulary yet, that can be done more or less automatically by the PoolParty extractor, and the new candidate terms will be pushed into the enterprise vocabulary, and from there on it could be become a concept of the enterprise vocabulary. So that's the whole idea here of this PoolParty power tagging. Yeah, and once again, remember, why is concept tagging so important? Because it's a precondition for semantic search. Otherwise, that won't really work on top of only algorithms. So that's how it looks like for SharePoint. So power tagging for SharePoint is here you see a dialog. Probably you have just put in a text in your SharePoint, and the tagging dialog will help you to find the right concepts to tag your content with. And later on, of course, all the synonyms and so on can be stored in the SharePoint Termstore and can be indexed together with your content, which means you're going to have all the information you have in your enterprise vocabulary to annotate and classify your SharePoint content. Another feature which might be interesting for some of you is you can build your enterprise vocabulary within PoolParty Thesaurus server, which is pretty comfortable also to manage large thesauri. And later on you can store it on your PoolParty server as a MMS, which stands for Managed Metadata Service, or also you could call it Termstore Management or SharePoint Termstore. And this enterprise vocabulary you've built with PoolParty can be reused later inside SharePoint. So there's an interface now, and you can export it or actually store it on your server. And once in a while, SharePoint will come and import it again into the Termstore. And as you can see, there's also URIs you can store together with your terms in SharePoint, so you won't lose the information if you change, for instance, some labels in your thesaurus. Then the same principle was provided last June on the Atlassian Marketplace for the enterprise wiki called Confluence. That's one of the most often used enterprise collaboration platforms. So Confluence now has a plugin called PoolParty Power Tagging. You can do automatic free and concept tagging here once again. Then all the synonyms will be collected and indexed together with your content. And there's also content recommendation here. So you can display similar content from your conference installation or even from Wikipedia. So you write about a certain area and topic, and you store it in your conference server, and then the system will collect information from Wikipedia, which probably helps to broaden your context around this content. So that's a functionality of this Confluence plugin, which is available on the Atlassian Marketplace. Okay, so now we come to the concept-based semantic enterprise search as part number 5. So one integration we've done recently was with one of the Gartner calls them challenger in the area of enterprise enterprise search, company called Fabersoft. They have a product on the market called Mindbreeze. Mindbreeze is an enterprise search platform, and here we've done a deep integration together with Fabersoft to provide semantic search. So that slide is in German now. So you see there someone is looking for something in the area of tax law and types in a search query. And the index was already enriched during indexing time. So it doesn't matter if he found the right words or the words used by the administrative authorities. It can use its own words. As a citizen, you usually talk completely differently than the people working in the public administration, at least here in Austria, but I assume it's the same in your country too. So this tool really helps to find stuff from the finance ministry, although you're not an expert or a tax law lawyer and things like that. So how is that possible? Actually, the whole architecture looks like that. So on top you see the Mindbreeze solution. There is a query service somewhere and the end user. And this query is already enriched by the PoolParty extractor, which means there's a query expansion done. But in this query expansion you can control completely with the Thesaurus manager. So here you say, okay, what are the synonyms of a certain label and so on and so forth. And that's already when you indexed all your documents. It could come from Sharepoint, from the web, wherever. The index will enriched already when the documents are indexed. So that's the point. You don't have to re-index everything when you make changes on the Thesaurus. That can be done on the index itself, and that's one of the highlights of this solution from a technical point of view. It's very flexible. If you change anything on your semantic layer, search will follow instantly. And the system also more or less learns from new incoming documents. So if there are new words in it and new phrases and concepts are mentioned, they will flow into the Thesaurus manager with this push API I just mentioned before. And also all the queries will be analyzed and the system will learn. So if people are looking for a certain thing frequently, then it will be integrated in the enterprise vocabulary. So that's the whole system, very deeply integrated with this search engine. And yeah, this whole principle, of course, can be done also with other search engines. There is one integration on its way together with Exalead, for instance, the French search company, which is also similar to this one. And it's available for Windows and Linux. Okay, now we come to the live demo part. So Juan will step in once again. Now we are talking about the third step of enterprise semantics. You remember, now we're talking about the really complex queries we want to make over all of our databases and different unstructured and structured text. Actually, now we have all the precondition. We have the vocabularies. We have means to describe or to map our data into this one single data model. And now we will take a look on it. How could that really work like? So I will hand over to Juan now, and probably you explain a little bit about our little demo application we've put together in the last few weeks.
Yes, thank you, Andreas. So as you can see here on the screen, what we have done is that we've taken 3 sources. The first one on the left is a standard Thesaurus of Economics, which is the one that Andreas has been mentioning before. The next source is the New York Times corpus. It's the corpus of all the New York Times articles. And then we also have taken data from the World Trade Organization about import and exports from countries. And this is stored in an Oracle, in a relational database, in an Oracle database. So the first, the standard Thesaurus of Economics, that has been managed by PoolParty's Thesaurus Manager. And then with this thesaurus, using the PoolParty search and their extractor, we've tagged the New York Times corpus with this economic thesaurus, and then we have linked the thesaurus to the data in this Oracle database. So now what we have is all these 3 different sources which all talk Sparkle, and we're able now to run these federated Sparkle queries, just one query, and be able to get information and answer complex queries which need access to these 3 different sources. So we'll give it back to you, Andreas, and maybe we can just show the demo immediately.
Yeah, maybe just to display that on a world map. Actually, it's really distributed, so that's something I have to point out. The one endpoint is located somewhere close to you, Juan, right? I don't know how many kilometers. Are you in Austin at the moment?
Yes, I'm in Austin, and that server is close to me, yes.
Okay, so the other one is also close to me, just in our office, and the third one, the virtuoso endpoint of the New York Times corpus, is somewhere in Germany. I don't know exactly where it is. It's one of our cloud providers. So what we really tried here is to see how does that work. Is it already stable enough? Is it fast enough? What were the improvements we have to make on top of such a federated solution? Of course, as I said before, you can pull together all the three data into one large triple store, and you could do that. That's no problem, of course. But the question really is, in which cases could this solution also be interesting for large corporations? You know, it's also from a legal point of view, it's not that easy to transport data from the US to Europe. Sometimes it's not even allowed. I mean, the whole data set. So the question really is, what if just portions of it will be federated together somewhere, maybe in Luxembourg? I really don't know. That's also a very interesting question. I would like to ask some lawyers. Unfortunately, we haven't found anybody giving us an answer on that. But it's an organizational question, it's a technical question, and it's a legal question if you do things like that. For instance, interesting point was when we started to optimize the queries. We made certainly some round trips because you know, if we look at the endpoint number 1 and find some performance issues here, it could be resolved somewhere else. It's not necessarily my data which is the bottleneck. It could be the data from my colleague in the other department somewhere else in the world. So that's a really interesting setup, we thought, and yeah, and now we tried to make that real, and now I switch over to an interface which looks like that and give you the live example here. Okay. So we have an interface like that, UltraWrap demo. So what we are doing right now, I do a little query about, okay, there are in Europe, here you have the region, like, okay, I want to know all the exports in the financial services area for 2006, for instance. So to find that information, you need two data sources in that case. You need to know which countries are in Europe. This information is stored in the standard thesaurus for economics. And then, of course, you need to know which exports of financial services were done in 2006. And there are also sub-concepts of financial service. There can be several ones. And that's also in the thesaurus. So all this hierarchical information is in the thesaurus. And the rest, the statistics themselves, are in the UltraWrap Oracle database. So let's go for it. It takes a couple of seconds. Now it's collected, and the Sparkle endpoint in that case is the one on the thesaurus side. It makes the queries also on the UltraWrap side. So now the data was shipped from Austin to Vienna and put together on the endpoint of the thesaurus. And you can see here UK is the number 1, Luxembourg number 2, and so on and so forth. And now I do a little reshift in my thesaurus. I probably have to log in once again. So I log in the thesaurus I used for this query, the standard thesaurus for economics, or Wirtschaft in German. And here I do a little rearrangement and say, which of course is not correct, Japan is a country in South Europe, okay? So I just put in Japan. And I will do the query once again. Now you can see that's probably one of the advantages of this setup. You can do the semantic side or this hierarchical information in one single interface. So you see here's Japan now. And all the data remains untouched. So you can do queries over a large Oracle database, and how it should be put together you can control somewhere else on the thesaurus side. And that's something I think is very exciting, at least for me. Juan, what do you think?
Yes, this is, as you said, it's kind of the agile data integration and being able to, two different parties don't need to necessarily talk all the time. So you can make these changes and then you can have, be able to answer new questions that will lower the barrier, and you will be able to accomplish things with less amount of time.
Okay, now we are going over to the really very complex one. So those are the three endpoints we have to make use here. So the question was, find articles in the New York Times corpus about at least one of the top 5 exporters in a specific economy sector are mentioned. So obviously you need to know a lot or some things about countries where they belong to, then economy sectors and the hierarchical structure, and of course also the synonyms and stuff like that. And on the other side, okay, here in that case we, for instance, can look for articles where top exporters in 2006, and in that case we have financial industry once again are mentioned. And you will see it takes a couple of seconds. It's not that fast yet as we would like to have it in place. We are working on that, and we will give a webinar in about 3 months. We finally agreed upon in about 3 months we will give one, and here in the meantime we work on performance issues about that. So that's one of the points we really want to improve here, of course. But you will see it will deliver, and we've done once again something very agile here. The endpoint in Austin delivers the countries. The endpoint in Germany delivers the New York Times articles, and which country belongs to which region and which economy sector belongs to financial services is in the third endpoint. Yeah, and finally that's the result. So you can see here only countries mentioned which belong to the worldwide top 5 exporters, which are Germany, Canada, Japan, Singapore, Spain in 2006. Yeah, so those were the 2 live demos, and I would like to say that we will open up the microphones in a couple of minutes. So if you are interested in discussing about that, just remain in the webinar, please. Don't leave the room. And after 1 minute or so, we will open up the microphones. So at the moment, I couldn't open up all the microphones. It would be too noisy. So please just remain in the room if you're interested in talking with Juan or with me, or just discussing this approach. Would be very interesting to get feedback from your side. Okay, there are a couple of questions from your side in the question sector of the GoToMeeting. I will go back just to the slides as well. So there's not much left to say here. Actually, once again, that's an overview what we've just showed live here. So instead of this undefined linking between the relational database and the text corpus, we have now this semantic layer in between, which helps us to find links, for instance, Spain and the abbreviations for each country. That's something you can link easily with the thesaurus and things like that. Okay, so going back to the questions. First question is a pretty easy one. Are slides provided afterwards and the recording of the webinar? Yes, we will provide such. Hopefully the audio quality was not too bad. Finally, we managed it just in time. Yeah, and then the second question was how you will find out the term is meant in the content in spite of homonyms. So you're referring, for instance, to this pipe thing. The pipe could have many meanings. Yeah, usually Okay, that's a problem, of course, which can't be solved 100%. But on the other hand, especially in an enterprise context, we are not talking here about the whole world. So I would say Google has a bigger problem about homonyms than enterprise solutions have, because if we're talking about pipes and you're working in a company which is providing such technical equipment, you most often don't talk about the pipes you're smoking tobacco or something else inside. So that's the point. Homonyms are not that big problem in the enterprise sector. There are other problems which are much more important, I think. Juan, what do you think? Do you have an answer on that? The homonym problem?
Well, I guess it's one of those open questions in computer science in general that's for several decades, I would say. But I think tools such as PoolParty will help the workflow for people to be able to accomplish what they want to do.
I mean, another approach also is if you do only the term-based analytics of your text, then pipe is pipe, and it will occur together with different other things. If you have two concepts in your knowledge graph, which both are called pipe, then they are related to different things. And if you do that together with text analysis, for instance, you really can make a much more precise guess which of those two pipes actually are meant in this case. You can analyze the sentence around a certain pipe and look up in the thesaurus what's related with the one or the other pipe. And then you can make a much more precise guess which of those two is actually meant. So that's actually one of those big arguments why you should invest into building up a knowledge graph in your enterprise. So these typical statistical co-occurrences, things like that, those algorithms are not that precise. So the next one was, do you think that SharePoint is the right ecosystem? Well, yes, I think so. I mean, actually, I'm not the one who says SharePoint is better or worse than anything else. It's just a matter of fact that a lot of enterprises use SharePoint for several reasons. So I really think it's a system which is well established and can help a lot large enterprises to manage document collections and things like that. What I only see is that semantics is pretty weakly built in at the moment. So the Termstore of SharePoint does not support the maintenance of really large enterprise thesauri. And if you really want to go into this direction and try to extract meanings and semantics out of your SharePoint content, you gotta go into this direction I just pointed out. So if we go back to the slides, actually, that's the conclusion here. SharePoint is yet another data silo. And you should not store the semantics of your enterprise inside one of those silos. You should really do that separately. And if you hook up your SharePoint content into your semantic layer, you can link it or mash it up with stuff from other databases later. That's the point. You can ask queries like, show me all SharePoint documents in which products are mentioned where our sales effort increased in last 2 years. And then probably the sales effort you have in another database. It's always the same principle, but the point is don't store the semantics in one of your silos. They should be explicitly stored somewhere else, and that's the point. So SharePoint is a good ecosystem or part of the ecosystem. It's not the point to do some bashing here or something. Okay, is a Smila plugin possible, or usage together with Lucene. Okay, Smila is a platform, an open source platform for search, enterprise search. I think it was built by Prox Solutions in Germany together with I think Intensity, I'm not sure, and a couple of others. And yeah, I mean that's the point. Of course, this kind of handling enterprise vocabularies together with other search solutions is such a general approach that it can be integrated into virtually any search engine. So of course also with Smila it's possible, and with Lucene we've done it. So for instance the PoolParty search server, which is part of the product family, is based on Solar or Lucene in its core. So that's of course a good approach to integration with several other Lucene search engines too, of course. Next one was I need to understand how you integrate your semantic tool with sensors, sensor data integration. That's a good one. I mean, first thought would be how would you like to store your sensor data, with which tool or with which database. First thing which comes into my mind is since you have a really large or big data in place, you probably go towards a Hadoop solution or maybe also an Oracle solution. I'm not an expert on that, but yeah, so I hand over to Juan. What do you think? Sensor data and linked data integration.
For sensor data, no, this is an area also that I'm not completely familiar with. I don't have much to say.
Okay.
Well, what I can say is that the mappings, those should work. I just don't have knowledge of sensor databases that are.
Yeah. Okay. Yeah, sorry about that. Maybe if you're still in the room, please remain and we will open up the microphone and maybe we'll find a solution by talking to each other. Yeah, I mean, I'm fully aware it's a very hot topic, data streams and sensor data especially. I mean, it's usually very numerical. Semantics probably doesn't play the biggest role here, I would say, at least not word semantics or not even sentence semantics. Not sure how decentralized data will be collected here. Of course, if you talk about things like in Europe, you have Inspire directive to at least be able to harmonize geographical data, which are always a large portion of sensor data. We are probably in the middle of the discussion already. So we probably should refine a little bit what exactly you mean by sensor data here. So that's the point. So please just stay and we will talk about that.
Yeah, Andreas, Andreas, sorry, that was my question. Yeah. Is what type of sensor or stream data? Is this like weather data, or is this like social streams like Twitter streams? So that would, so if the person who asked the question would stick around at the end, we would like to continue that discussion.
Yeah. Yeah, next question was, so how is the indexing done, the extraction actually, the extraction of semantics of text, for instance? Is the data sent to the indexing server, or is the code executed on storage servers? I mean, both is possible. For instance, if you're talking about Sharepoint integration or Confluence integration, there's an extraction server, and this extraction server consumes data from various data silos or data sources. So the data is sent to this server. Of course, you can set up and install the server inside your firewall. It's not sent via the internet. It's just a service in your enterprise service bus. So the text is sent to the service, and the extracted semantics is sent back as an RDF graph, more or less. And this actually it is an RDF graph. And this RDF graph or SKOS graph can be used either to be stored together with the URI of the tagged documents inside the CMS or the actual data source, or it could be stored in an index or in a triple store. So those are the three versions, flavors you have, but in general we really leave it open to the architecture. So our approach is you have the extraction server, which follows the knowledge model you've created with the PoolParty Thesaurus server, and from there on you can forward it into store all the data in a large triple store, or you can return it back to the original source and store, for instance, all the tags and concepts together with your document. Both is possible. Is this technology compatible with Arabic languages? Yes, absolutely it is. We have implemented right-to-left languages like Arabic or Hebrew or some languages spoken in India. There's also Chinese and Japanese available. Actually, all the UTF-8 encodings are supported. And also from the interface side, right-to-left languages are fully supported. Okay, then we are talking about a concept-based search. Then you must know which pipe you mean. Yeah, that's the point. It's we talked about that before. The pipe you mean is the pipe which is in your knowledge model. If there are two pipes, we can try to disambiguate and find out if it's the pipe which has context A or the pipe which has context B. You have a context represented in your knowledge graph of both pipes, and you have some context represented in your text. And now we try to find out by doing some text analysis on the one side and graph similarity on the other side to find out which pipe is meant. Our algorithms are not like also people don't always know which pipe is meant. That's the reason for the this confusion. But I would say knowledge-based text extraction or thesaurus-based text extraction can deliver more precise results here than the simple text mining algorithms we had in recent years. Okay, store in an RDF store or triple store, for example. That's not clear. What's that? If you have heard of the semantic sensor web, then it would help to answer social streams or sensors that monitor environmental phenomena such as temperature, humidity, and light. The data values from these sensors are stored in a database and are queried using Spark and retrieved and displayed or integrated on the semantic web for data search and analysis. I mean, it sounds like people working in the sensor web field embrace more and more semantic web standards because they need to integrate in an agile way, obviously. The question really here is if Thesauri are the right integration tool, which are more, let's say, language-oriented, or if you're rather looking in that case for OWL models, knowledge models, to make some further reasoning about your data set as well. I really don't want to exclude the OWL way for linked data integration here. Just want to point out the difference and the different application areas. So, but that's an interesting question. I really would like to discuss. How do you cope with terminology harmonization in different languages? Well, actually, SKOS provides language labels for each concept. So we provide thesaurus alignment cross-language-wise. So if you have cat, katze on the one side and I don't know, jaguar and jaguar on the other side, and that's connected with katze as well, then we are able to do a close match here. Although it's in different languages. Of course, the thesaurus needs to have the information which concept is behind, but a German or French or Spanish thesaurus, of course, can be aligned with an English one if you have the translation layer in between. There are a couple of tools for that, but it's possible to do that with SKOS in general. That's the point. So this specification of W3C supports multilingual thesaurus alignment too. Okay. So that were all the questions I had in my question box. So I will hand over to Juan once again. Do you want to say something in addition to what we've discussed here?
No, as you mentioned, we are going to continue working on our demo, and hopefully, as you said, in 3 months have a new webinar and where we can show the performance improvements about everything we can do. And thank you, everybody, for your time.
Yeah, same from my side. Thank you for your time. It was exciting once again to have you with us. And as I've said, please remain in the room if you want to have some discussions in about 2 minutes or so. So I just leave it as it is, and in 2 minutes I'm going to open up the microphones of all of you who remain in the room. Okay, thank you very much. Good evening, good morning, and so on and so forth. Bye-bye.